Okay, we now have our Arduino robot, our BOE robot or BOE-Bot, moving. And at this point, we are going to do a little activity which we'll call Robot Golf. And we're going to call it golf because there's going to be 9 obstacle courses that can be completed using nothing more than motion instructions. Okay? So it'll be everything by these are designed to be tape this on the ground as like a little course using electrical tape or something, and start here and end within one of these boxes. So you're going to get experience for going straight, turning left, turning right, doing smooth turns, spin turns, circles, and then trying to interact straight lines. But the question is, why do this? So the big one is you want to start gaining experience with locomotion. Okay, the robot, moving around is one of its big tasks. It's one of the main things that it does. So just getting familiar with what you need to do and the settings to do motion. The second big one is to see how the electrical, mechanical, and the computer program components interact. What you're going to notice immediately is that you may have a instruction such as move forward that you think should move it in a straight line. You send the exact same settings to both servos and the thing won't go straight. It'll kind of veer to one side or the other. And that's because the program thinks that the servos are perfect. However, these servos are not perfect. So maybe one of them is a little bit weaker than the other one, and all of a sudden you're going to have to go into the program and compensate for the weakness of one of the motors in order to get it to go straight. The other thing that will happen is that your batteries are going to be wearing out over time. So the electrical part of this becomes really critical. Is you'll be programming and your robot won't be responding like you think it's supposed to respond, and you'll get very frustrated because it's not doing what you're thinking about. You're trying to get it to do all these things and it's acting erratic. Well, one of the things the biggest thing that happens is you just wear down your AA batteries and you'll need to replace them. And so what happens is that you call it a brownout, where the voltage drops low enough that the computer will actually reboot, but it's not so low that the computer shuts off. And so you'll get into this perpetual rebooting of the computer. So it'll actually be moving around, but it's just not working the way it's supposed to. So it might work for a couple seconds, then it reboots, and it works for 10 seconds, and it reboots, and it'll drive you nuts. So it's this whole idea of the computer program. It's not interacting with a real perfect system. It's working with a real world system. And so you have to account for that in your program. Okay? The other big one, this is huge, is that you are going to be copying and pasting these locomotion instructions. So right microseconds to go forward, to go left, turn right, spin left, spin right. And your code is going to become unreadable very, very quickly. You're going to open your sketch and you're going to look at it, and you're going to have 100 lines, and you can't tell what's going on even with the best comments. And so you're going to go, geez, I keep copying and pasting the same code. Wouldn't it be great if I made my own function to move forward, or my own function to halt, or my own function to spin left and spin right? So it's going to really drive the motivation for why we code things in a modular fashion. Whenever you have something that is a chunk of code that's repeatable, or something that you will be using over and over, you don't just leave it in your main loop. You put it into its own routine or function, and then you can call it. The other great thing about that is you can name the function something descriptive, like forward. I mean, it's like you call the function and it moves forward, and it's fantastic. Okay. The other thing is going to be, we're trying to basically drive along these lines and then stop somewhere. And you are doing this in what we call an open loop configuration. You are just going to set it off, wait for a certain amount of time, and then have it stop. And you're just going to kind of guess and check until it lands. Well, one of the things that you'll immediately notice is that it would be so much nicer if you had some ability to sense the world around you. Particularly if you had a sensor that could actually track the line, then your code could become very intelligent. Okay, you could build a robot that, instead of just saying move forward as fast as you can for 10 seconds and stop, it would be like, just track this line until you get it to an open area and then stop. and that would give you a much more sophisticated robot, and you would be approaching a autonomy where the robot is able to accomplish tasks for long durations of time without human interaction. Okay, so here we go. We're going to call it golf because there's 9 obstacles. We'll just call it a hole, just to keep the naming consistent with golf. And just, you can tape these on the ground. Okay, so do this anywhere. What you're going to do is we're going to start with the first hole, and it's called a short straight line. So this is the most simplest one. You're basically going to have 3 feet of a straight line, and then you're going to end in a box. The boxes are always 1 foot by 1 foot. So essentially what you need to do is start behind this line. You need to drive 3.5 feet and stop. And you're going to start behind this line, so you could conceivably say you're going to drive a little bit more than that. The way we're going to do it is we're just going to do it by time, and so we'll go ahead and fire it off, and let's start with our ideal settings of 1550 and 1450, which is going to move both servos forward. We'll notice immediately it might not go forward. Okay, so let's go ahead and fire up a new sketch. And when you do this, you should do 1 sketch for every hole so that you can come back to it later. So let's go ahead and fire up our new one. And once we get one of these, we'll do a lot of copying and pasting here. So I'm going to save this. And we'll go ahead and go into our Arduino folder that we've been working in. And I'm going to call this, I'm going to go ahead and call this, I'm going to call it Chapter 3 just because it has to do with locomotion. And I'm going to call it Golf Hole 1 Straight Line. Okay, now I'm sitting here with this sketch, and I need to type in everything that I just typed in. I'm going to go ahead and I'm going to bring up my prior activity, and you'll do this over and over and over, and I'm going to copy and paste the whole thing. Okay, so I do Control A, it selects everything in my sketch. I do a Control C, and now I can go into here, and I'm gonna delete everything out of here, and I'm gonna paste everything in there. Okay, you could have copied the file over, but this is sometimes nice because when you make a new project or sketch in Arduino, it creates a folder for you and all that sort of stuff. So now I have this thing, okay, and what I'm going to do is start going through it line by line, and I'll see if it works. So I've got my include servo left, servo right. I've got my void set up. That's my print monitor. Might not use it in this one because on these I'm going to detach my cable. I'm going to attach the servos to the pin 11 and 12, and I'm going to stop the servos. Now I can print this to the serial monitor. Even if I don't have the cable attached, it's fine. It'll try to send it up. It'll send the information. It's just it won't go anywhere if the cable's disconnected. So that's fine. I'll go ahead and leave that there. And then I just want to move forward for a certain amount of time and then be done. So let's go ahead and delete all this other stuff except for the final stop. And now I want you to think about something, okay? I'm in the setup loop, okay? I'm in the setup portion of the Arduino program. I want to stop, but I want to stop forever, okay? So I need to somehow continually stop, and will this work, okay? So I'm going to do each of these one time. So I'm going to stop the engines, or stop the servos, and then I'm going to move forward for a certain amount of time, and then I'm going to do this command, and then I'm going to get into this loop and stay forever. Does that work? The answer is it does work, and the reason is that when I send these last servo signals, these stay stills, they will be on forever until I change them. So in fact, I actually don't even need this delay on here. It doesn't make any sense. And I send these one last time at the end, and I'm done. Okay? So I not just stop these for 1 second. I'm going to say stop. Okay. This one right here, I'm just going to say move forward because I don't know how long I'm going to go. And I still have my message here. That's fine. And I'm ready to test this out. I'm going to go ahead and say, let's go ahead and have it move forward for 2 seconds. And I'm going to go ahead and upload this. Okay. All right. I got my serial monitor here just to make sure that everything's going. And remember, I can run this program over and over. So I have my robot, and I have hole 1 on my desk. Okay, so I tape this on there, and here it is. And when this fires off, here it goes. So I move forward for 2 seconds. Let's test it again. I hit reset. Here it goes. 1001, 1002. There it was. Now, I got my program on there. It's time for me to actually disconnect the serial monitor. Okay, and I'm going to go ahead and I'm going to put this down here, and I will see what happens when I hit reset and have it go. Okay, so I'm going to test out the robot. Okay, so go ahead and go boom. Alright, so here we go. Okay, 1001, 1002. So I can hit it right here. Let me get some more information on that. I hit reset. It reboots 1001, 1002. So, absolutely horrible. I made it I made it like 20% of the way there, and I started turning right. So this is just horrible, and it's going to take forever. So this program is horrible. Let's go in and adjust it. So the first thing I want to do is that it's running way too slow. So I want to move this up. In fact, let's just full throttle it, okay, because that was just way too slow. I'm going to increase the speed, so it's going to go further in 2 seconds, but I know that I should probably go a little bit further than that. So I know I got to go farther. So let's go 4 seconds. Okay. So I'm going to go ahead and I'm downloading it. Don't have the cable connected. So I go ahead and connect that up. It dings. And I go ahead and do it again. Okay. So I go ahead and run it. And it's nice to have that serial monitor on there because it lets you know what's happening. Okay, much better, much better. So now I'm going to go ahead, disconnect it, and let's move it down to the other end, and let's see how good this does. Okay, so all right, here we go. So I pop that baby down there, I hit reset, give it a second, and let's see. It's going to go way faster. Not bad. I'll tell you what, when it went full speed, it did not turn very much. Alright, so here's how far I made it. I basically made it 2 feet and 2.5 feet. Okay, so just guessing and checking. I bet you if I went another, I don't know, another second, I'd be golden. So let's go ahead and do that. Take this, plug in my cable. Okay, and go ahead and download it. If you get those red messages where it gives you something funky the first time you plug the cable in, just do it again. Sometimes this gets caught kind of in the middle. Okay, now we're cooking. Alright, so let's go ahead, disconnect our cable, and we'll come down here, and let's see how good we do now. Okay, and I'm going to go ahead and hit it. Boom. Now, here we go. I'm going to go in 5 seconds. Here we go. Oh, it's off. But does it make it? It's so close. Look at that. I made it just a little bit further. We got to go what? You want to go 7? 1,001, 1,000? I bet 7 does it. I bet 6,500 does it. Okay? You get the point of what I'm doing. All right? So all you're going to do for these simple ones is get used to how this thing operates. Okay? You watching me sit here and guess and check, you know, maybe it'd be a better use of time to have you write this program, and that's what you're actually absolutely going to do next. So here we go. Let's test my final one, and then you can give it a shot. So let's put this back over here, line it up nice and square, and hit the reset, and there it goes. Okay, can it do it? I gave it an extra 1.5 seconds. Boom, right there. How unscientific was that, though? Honestly, all we did was just go straight, and we just guessed and checked, and that's fine. We are building experience with programming this BOE bot, and that is exactly what the intent is. You can kind of see, it's like, geez, maybe I should have calculated the circumference of the wheel and figured out how many rotations. You will do that eventually, but for right now, we're just building stick time. So here's what you're going to do. Go ahead and stop the video and do hole number 1. Okay, I'm going to walk you through the first couple of these, and then you can do all 9 on your own. But this would be a good time to go ahead and give this a shot. And so go ahead. Okay, so now we are on to hole number 2, and this will be the last one that I do, and then you can kind of do all the rest on your own. So hole number 2 is where we're going to go. It's called a 90-degree right turn, and we're going to go 1 foot, spin 90 degrees to the right, and then move forward and end in the 1 foot box. Okay, so what's interesting about this one is how we can reuse the code from hole number 1 and just get used to this whole copying and pasting mentality of code reuse, okay? So here's what we're going to do. What I want to do is I want to bring up the Arduino code from hole number 1. And so here it was, just move forward, just very simple, and it worked. But we know one thing that's really interesting about it is not only did it work, but with these settings of move forward, that corresponded to a little over 3.5 feet. So let's go ahead and just take this sketch, and I'm going to go File, Save As, and I am going to go into here, and I'm going to rename it. Instead of being Golf Hole 1 Straight Line, I'm going to name it Golf Hole 2 Right Turn. Okay, so right turn. And it creates a new sketch, new folder, new sketch, and now I'm up and running. So let's think about what we could do here. We know that this setting, we know we're going to want to go forward, but we're only going forward a little bit more than 1 foot since we start behind the line. So we need to cut this baby in maybe about 1/3. So let's go ahead and just cut that in 1/3 and see what we get. So I'm going to type in, I don't know, 2167. Let's just split it right in 1/3. Okay, then what we want to do is we're going to do a right-hand turn. So I'm going to copy and paste this just so I have some code to work for them. And I'm going to go ahead and I'll print out spin right. So I'm going to go spin right 90 degrees. 90 dg. And what's our setting that we need here? So I need to be the left servo goes forward, left servo forward, right servo backwards. So what I need to do is I need to kick this up to 1700. Now when I do this, I'm going to slow it down just a little bit. Something I've kind of learned is that the turns, you don't need to go as fast as you can, so sometimes it's better to kind of turn a little bit slower. So I'm going to slow these down just a little bit. Instead of going all the way to 1700, I'm going to go right in the middle. I'm going to go 16 on each. And the key here is that I got to take a guess at how long I'm going to do that. And so I'm going to, I don't know, let's guess 525, and then we'll tweak it as we go. And then I need to go forward again. So at this point I've gone up to here, boom, turned right, and now I need to go forward. Let's go ahead and I'm going to copy my forward again, and I'm going to put it down here. And I've got full speed again, and I need to go forward. I probably need to go a little bit further than 2167 because I'm going to go into the box. So let's just guess at something like 2750. Okay. All right. So here we go. Let me save this, and I'm going to bring up my serial monitor. And where did it go? So here's the serial monitor. So I've got that on there right there. And let's take a look at our course. So I have my course laid out. I've got foot, turn right, foot, and then I got my landing place. And what I want to do at this point is I'm going to show you a few things. First of all, when you download it, go ahead and connect the cable and put the power into position 0. And the reason you do that is this. I'm going to go ahead and download this. But with the power position in 0, it'll download it to the Arduino and it'll run it, but it won't take off. And the reason I do that is because I want to see the serial monitor actually work. So, okay, stop the service for 1 second, move forward, spin right, 90 degrees, move forward. So I know that my program's on there, and I was able to verify the program was on there before I even tried this thing. So now what I'm going to do is let's go ahead and remember the program's on there. So I can go ahead and detach, and I detach that thing, and I'll go ahead and now I'm ready to go. In order to run the program, what I'm going to do is I'll set it up here. I put my power back into position 2, and I hit reset. And then we'll see if those settings were correct. So I hit reset. It's going to fire up. Here we go. Forward for a second. Turn right. Did it. All right. Now you might go, wow, those were some really good guesses on those amounts right there. Well, it turns out I did this beforehand, so I had the values written down. So I did guess and check for quite a while before I came up with those exact values. But check out what we just did. We now have the settings to move forward a foot. We had the settings from last time to move forward 3 feet, or 3 feet plus. We have now, this is a spin right 90 degrees. This right here should be locked into a subroutine or a function and saved for all time. So that's something we can copy and paste. And so this is fantastic. So here's what you're going to do. Go ahead and fire that off, but let's look at the other holes and look at the challenges and talk about code reuse. Hole number 2 goes into hole number 3 like this. Go forward, turn right, go forward, turn left, Now check this out. We already have the code to go forward and spin right. We have the code to go forward this amount and spin left. What about spin left? How does it relate to spin right? Shouldn't it be the exact same amount of time of spinning, but with the motors going the opposite direction? So we got it. You can copy and paste your sketch to hole 3 and go ahead and do that. Hole 4. At this point, you're going to be like, okay, wait a minute. I want to actually do a function. All right, so this is, I want that spin right, spin left thing to actually give me a function. So let's look at how you would create a function. Okay, so the first thing we're going to do is I'm going to do this sketch. So I'm going to pull up my Arduino, and let's go ahead and do this. I've got this code, and I want to go File, and I'm going to go Save As. And I'm going to go ahead and do it as hole 3, turn right, right turn, left turn, and I go ahead and say, okay, now here's my new sketch. Okay, so how am I going to do this? Here's what I do. I'm going to come down here, and you put functions after the loop. Okay, so what I'm going to do is I'm going to put a bunch of line functions here, so I know that this is my function area. So I go ahead and I do that. And then I'm going to do this, and I'm going to say function, and I'm going to call it, what do you want? Well, let's call it turn right 90. So turn right 90. So that's the name of this thing. So how do you do this? I mean, how do we actually do this? Well, what you're going to do is you're going to make a function that looks very similar to this. You're not going to have any parameters that are passed in, and you're actually not going to return anything. So we can actually put the void right there. So I'm just going to do this. I'm going to go void, and I'm going to give it the function name, turn right 90, and then I just do that. And all I do is I open up a curly bracket, and it closed a curly bracket for me, and I'm going to take this spin right 90 or turn right 90, and I'm going to take this and I'm going to cut it, Control X, and I put it down there. That's what's going to happen when I spin. Okay, now this guy right here, we don't really need it anymore. We kind of want it in there. Let's see this, redo that. Oh boy, we want to redo this. So redo, Control Y is what it is. Control Y. Okay, so there it is right there. I want that serial print in there because it helps me figure out where I'm at. But I'm gonna go ahead and move it up here. So at this moment, what I want to do is I want to say spin right. How do you call that function? All you do is you just say turn right 90. So I come over to here and I just say turn right 90. And that is my function. So the first thing I want to do is let's test this. Okay, let's test this on hole number 2, which I still have set up. So I'm going to go ahead and fire this baby up. Turn that back to position 0 so that it doesn't take off on me. And I'll go ahead and download it. Okay, got a red message in when I first plugged it in. We have a problem here. Oh, forgot the semicolon. Go ahead and save that. Boom. And off we go. Waiting for it to go. Life is good. It compiled. I'm going to wait for the monitor over here to make sure that it worked. Stop the servos for 1 second. Move forward, spin right. Bam. It worked. Okay, so life is good, and we can test. We can make sure that it actually worked here by putting it onto here, and go ahead and turn on the motors, hit reset, and make sure that worked. Okay, piece of cake. Alright, so turn off the motors, and let's go ahead and throw, you gotta be gentle with these batteries. Let's go ahead and make hole number 3 now using the functions. Okay, so I'm going to come in here and I'm going to come down to my function that I have right turn 90. I'm going to copy that. I'm going to copy it. I'm going to come down here. Let's get that last curly bracket. Copy it. Boom. Come down here. Boom. So now I have function turn right 90. This is going to be my turn left 90. So I'll come down here and I'll say turn left 90. And what should be different? Well, this is about the same amount of time, except that I just want these guys to spin the opposite way. Now, you gotta be careful with your comments, because when you copy and paste, sometimes you forget to update them, so I'm just gonna nuke them for now and update them later. So I got that, boom, I got turn left 90. So now I have a new function, and look at, I copied and pasted it, and all I did is change the settings to equivalent settings. This is fantastic. So let's go back up here to our main program, and let's walk through it. I'm gonna do stop the servos, and here's where I start. Move forward for that amount. Perfect. Spin right 90. Look at that. All I did was call a function. Then I did a move forward again. That should be a function too. And now watch this. I'm going to turn left. I copy and paste my function turn right. And I'm going to go ahead and say spin left 90 degrees. And all I do is now call that function. This is great. And then I move forward for a little bit. Now, one thing to keep in mind, I move forward for 2167. I should probably... I got to put one more forward in here, so I copy and paste that, and that was the good. 2750 was about to go a foot and then go into the box. So this right here is probably going to be less than, let's make it 2000. It's probably going to be less than this because you're only going a foot. So there's a pretty good program. Let's go ahead and plug in Arduino, put it to switch 0, and there you go. All right, so didn't work, but that's all right. Okay, now let's see what happens. Okay, move forward, spin right, move forward, spin left. Okay, so now we'll move this over as if there was a line there to do this, and let's see how this works. Okay, so I'm going to come over and see how close we are. Okay, so I turn it over to here, go back position 2 for the power. I hit reset, and let's see what we do. Totally drew the wrong course. So hang on a second. We want to go right, turn right, then left. Okay, so here's what we want to do. Let's just see if this kind of looks like it's doing the right thing. Right, left, and then forward. Okay, so here we go. So forward, right, forward, left, forward, stop. So there we go. So without we would draw that on the ground and then do that again. But more importantly, what have we learned here? We learned how to create functions, and it makes everything not only great and modular because you can reuse these over and over, it makes your code readable. Because look at this, I'm up here and I'm like turn right 90. That's obvious what I'm doing. Turn left 90. It's obvious. How about move forward? Why don't we put these into actual functions? So you're gonna, as you go along, start putting things into functions, and it's just great. Make a forward, make a turn right, make a turn left. Okay, how about the rest of the holes? Hole 4, you're gonna do a smooth right turn. This is not a spin turn. You're gonna have both wheels moving forward, and you're gonna gently go on a 2-foot radius on a 90-degree arc. So that'll give you experience with a smooth turn, and at the end you got to go just a little bit forward straight. Make a function for that. How about doing the same thing, smooth turn right, smooth turn left? Those are going to be 2 more functions that you can put into your own code library that you're building up here for more control of your robot. Then how about this? Let's assume there's an obstacle there and you want to do a nice 45-degree turn. So go ahead and turn right 45, left 45, forward. Here's more functions you could create. You've got a turn right 90. How about a turn right 45 and a turn left 45? The settings should be identical for the motors. It's just that you don't do it for as long. So instead of doing 525, do 200 and, what's that, 260 something or other, 262.5. So just change the degree or the delay on that. Look at how you're building up all these functions. 7, how about a smooth 6-inch radius? Smooth right, smooth left, smooth right. Now you have kind of a smooth, shorter turn as opposed to that long sweeping turn. More functions. How about a circle? Why not? You're going to go out here and you're going to go on a 1-foot radius. This is mainly... you can write a function to do a circle, but this is mainly just to kind of get you experience with the settings of, like, if you're your settings aren't exactly right, you'll like spiral inward, because I want you to come down, go around this circle twice, and then go forward. And so you'll spiral in, spiral out. So it's kind of a challenge. And then the big one, 15 feet of a straight line. This is where you're going to be going nuts, because it'll veer off to one side or it'll veer off to the other. And so you're going to be messing around with trying to get it to go straight. And it's just like you're going along, you hit a little bump on the floor and it'll go off. And this is the one that motivates you to say, man, I wish I could just track that line. I need a sensor. This would be so much nicer to have a sensor to feed into my program. Okay, so that is your now big activity. Go ahead and put this golf course together using tape on the ground, and go ahead and complete these obstacles. Remember, copy or create a new sketch based on the old sketch for each hole. So you should have 9 programs at the end. And at about hole number 3, start putting things into functions and building up this library of functions that are at the bottom of your code. And then at the end of this, you'll be ready to do some pretty powerful stuff. Okay, good luck.